Welcome everybody, it's good stuff. This is April BS and Beer. So awesome showing and conversation last month. So we got another one tonight.
Thank y'all for being here. Again, my name is Chris Knight with New South Homes. We've got a great sponsor tonight, so I want to start by welcoming him first. Matt King with All Build. You want to come up and tell us what you do?
Matt King with All Build Systems. We're family owned and operated. We specialize in rain screen furring. So keeping your building drained and dry is our number one priority. We're family owned and operated. Like I said, my father-in-law is the one who developed the products. My sister-in-law, brother-in-law all work for the company. My wife is actually my boss, so I must have done something pretty good in a past life to be so lucky. The products that you might have seen out there before you came in, there's millions of feet of those across the country, and on all sorts of different project types, from large houses, tiny homes, off-grid homes, floating homes, saunas, convention centers, ski resorts, federal airports, municipal buildings. You get the picture. Just about every type of build out there we've been involved on in one way or another. Big thanks to Chris for inviting me out. Appreciate you guys all coming out as well, giving us the opportunity to put my company and our products on your radar. Big thanks to Carl. Looking forward to what you've got in store for us today. Come see me afterwards if you'd like. I'll be here till they kick me out. And one fun fact I'll leave you with, the earliest recognition of an architectural rain screen dates back to, does anybody want to guess which century? 12th century, 1130. There was a church in Norway that was built. It sits about 50 yards from salt water, so ocean spray. It is still standing today. Pretty incredible, and is largely attributed to the fact that it has a ventilated facade, aka a rain screen.
Thanks, Matt. I will say that I'm a big fan of the rain screen. I think if we want to build better buildings, we have to make it affordable, and I think it's a really good product for what bang for your buck. So if you haven't talked to him already, definitely check him out after this. Thanks for being here. I get to introduce our speaker, who I'm sure you've never heard of before. He is the principal at SK Collaborative, regular contributor to every green building magazine.
Formerly a contributor.
Once a contributor, always a contributor. So right. Please welcome Carl Seville.
So this is a variation on an architectural CEU we give out to firms. I adapted a little bit for this crowd. But I thought, for those of you who don't know me, I thought I would give you sort of my path to where I am now. I started Sawhorse. Matt was my employee when we learned about green building. During time at Sawhorse, I met Mike when, in 1996, I came over here and helped them build the yellow building. They were running behind, and Dennis Creed said, "Can you help me?" So I showed up, and we knocked that building out in like 3 months. It was a lot of fun. And I learned a little about green building then. Then they had this thing called the Earthcraft program. This is about 2000, or 1999, 2000. And I went to them, at the time all I did was remodeling, and this was a new home program. I said, "We need a remodeling program." So we all came in and took the Earthcraft class. I don't know if you taught it or not, but we all said, we have to tear our houses down and start over. And then I got involved in a committee that created the Earthcraft renovation program. We did all the pilot projects, and unfortunately, it didn't really go anywhere for a while. I've had a lot of interaction with Earthcraft in the past several years. I actually created the checklist that you now use for the prescriptive path for the Earthcraft House program. And we certify homes under lots of programs, including Earthcraft. We actually do a fair amount of Earthcraft Light commercial right now, different programs. In about 2005, I'd been a contractor for 25 years, was totally burned out, and I really wanted to start doing sustainability, and frankly, I was ahead of the market. It wasn't there. So I left. Started my little consulting company. I became a HERS rater, just seemed something interesting to do. I became an MGBS green verifier, which ended up turning into most of my business going forward. I became a lead AP Homes, a lead green rater, done a little bit of that. I wrote the first college textbook on green building with my business partner. I wrote most of the Lead for Homes reference guide. And for many years, I blogged as the green building curmudgeon on Green Building Advisor, which I finally stopped doing because I ran out of ideas. I became a FIAS rater 15 years ago, and I'm currently working on my first passive house. We're working what Matt refers to as the third passive house in Georgia. The first two didn't work, so we're working on the third one. And now I have a company called SK Collaborative. There's soon to be 15 of us. We do all kinds of work all over the country. Okay, on to the subject. Oh, and then I recently became a building enclosure commissioning provider with IBEC. And I found out I had all the qualifications, so I took a test and I became a building enclosure commissioning provider. International Institute of Building Enclosure Consultants. I was just at their conference. It was actually a very good conference. It was really interesting. Okay, so keeping buildings dry. Most are talking about frame buildings here. The reason we have to keep buildings dry is because they're not old. Old buildings were solid wood, had no insulation. If the roof doesn't leak, they will never go bad. I have a 100-year-old guest house behind my house that has no insulation on the walls. It's fine. The energy bills are high. They're not comfortable, but they dry. The air moves in and out. It dries the building. And they were made of really good wood. Heart pine is unbelievable. Now we have buildings which Joe Stieber likes to refer to as wood. You know, OSB, I-joists, all kinds of stuff, which is incredibly not resistant to water. It just, water will pulverize it. The buildings are more comfortable, theoretically. They don't dry though, because the water gets in and the water can't get out. So that is why old buildings that don't have weather barriers tend to be fine. The new building doesn't have a weather barrier, it's a disaster. We manage moisture, liquid moisture and vapor. These are the ways we do it. We're not going to get into all of them, but we're just going to talk about mostly the liquid, a little bit of the vapor. It's managed with a complete building envelope or building enclosure, whatever you want to call it that day. I kind of put this up here, the building control layers, for anybody who might not sort of be aware of it. The first one I refer to as the water shedding layer. That's going to be your siding or your brick, the stuff that basically keeps the bulk of the water off the building. It doesn't keep the water out of the building, it just keeps it off the thing that keeps the water out of the building. The next one is the water control layer, which is generally going to be your house wrap or your zip sheathing, something like that. And the thing is, it's not just the product, it's the system. It has to be fully integrated with everything else, all the windows, all the openings. Then you have the air control layer, which in most cases is the water control layer. It may vary slightly, but typically it's the water control layer. It is also the vapor control layer. Talk a little bit about vapor later. And then you have the thermal control layer, which is basically your insulation, your insulated windows. They all have to be continuous and complete. That's the key. The pen test. Who knows what the pen test is? Cool. For those of you who don't, you should be able to cut a section any direction through a building and draw a continuous line for each layer. This is the water control layer. It's continuous, goes under the slab. This is the thermal control layer, it's the insulation. This happens to be a commercial building, goes down over the face of the slab. And this is the air, and in this case, the vapor control layer. If at any point when you're drawing that line, you see a gap, you have something you have to fix in the building. That's the key. Continuous, complete, and connected at the changes. And that's the challenge, is the changes and the penetrations is the challenge. The water controller keeps the water out. Roofing, foundation waterproofing, the water resistant barrier, WRB is what we commonly call it. It's behind the wall finish. What I always like to say is, if house wrap looked great and didn't deteriorate, we would never have to put anything else on our buildings. But unfortunately, that's not the case, so we have to put something over it. And then we do a lot of multifamily work. Balconies are one of our biggest disasters. They are always done badly. The air control layer, it controls heat and vapor movement to the exterior, and then in multifamily between the units is really key. Continuous and complete. I'm going to continue repeating this. Seal the transitions, the plane changes, corners, roof, ceiling to wall. That's the place where you have to really watch out, where things do not happen. And the penetrations. I can't count the number of times I see somebody put the siding up and then come in and put wires and pipes through. Every pipe, every wire, every duct you put through a building without sealing it to the weather barrier is a leak. It is guaranteed to leak. It will only leak. It can't do anything else. You should not put any siding on the building until every penetration is sealed. If you're not sure, you stick a couple of pipes through the weather barrier and seal them and cap them at both ends so you can run some wires and pipes through later. There's always often in a new building, there's often a draw aligned with putting siding on the building and putting masonry on the building. So they do that sooner rather than later. And it needs to be later rather than sooner. The vapor control layer. So this is a variation of the drawing from Building Science Corp. They've actually changed how many quarts of water go through in a season, but I just stuck with this one because we've been doing it for so long. When I first got into building science in 2000, this is what brought it all home to me. If people talk about vapor control layers, And the challenge is that the vapor control layer is really not an issue in our climate. It's not an issue in most climates, actually, because vapor controls diffusion through a material. So if you take a sheet of drywall in a season, it will diffuse about 1/3 of a quart of water. You cut a 1-inch hole in that piece of drywall, and it will move 30 quarts of water by convection. Not convection. Infiltrate, sorry, yeah, sorry. It will move, so the vapor control layer doesn't really serve a lot of purpose. It's the air control layer that controls it. And the best way to describe this is the seasonal changes here. When you have, in the summertime, it's very humid outside, and you air condition the house, and the air conditioning drops humidity. If your house is very tight, humidity will stay down. You probably experienced that, right? If your house is leaky, as soon as humidity goes down, all the humidity from outside starts running inside, and you have to keep air conditioning to lower it. And conversely, in the wintertime, it's very similar. In the wintertime, we tend to create enough moisture from bathing and cooking and breathing to keep the house fairly comfortable. But when it gets down to 20% relative humidity outside, if your house is leaky, all the humidity outside is going to go out. That's why your house feels dry in the wintertime. So people who think they need a humidifier, in most cases, need air sealing. That's really, really what you start looking at. So basically, air leaks allow vapor movement. Depressurization allows vapor movement. We see a lot of multifamily projects we work on, they have a central return in the living room. So when you shut the doors to the bedrooms are overpressurized, it's pushing air out. The living area is underpressurized, it's pulling air in. And if the building is leaky, there's a lot of air and moisture coming in that way. Leaky ducts do this. Exhaust fans are my favorite. When people put 1,200 CFM range hoods in a house. How many tons of air conditioning is a 1,200 CFM range hood, Mike? How many tons is that? What do you? It's about 3 tons of air conditioning in that 1,200 CFM range hood. And people do it all the time. And that's going to that'll depressurize almost any house, even a well-sealed house. Maybe not Corbett's house, but anybody else's house. If there's no pressure differential, there is no air movement. If there are no holes, there is no air movement. So wind creates pressure differential, so that's one thing you can't control. But you make a super tight house and you balance it well inside, you will have limited air movement, limited vapor movement inside to out. One of the actually back to your question about in multifamily, sealing the drywall is the drywall is often the air seal between units in multifamily, so that's a lot of air seal there. The thermal control layer, it's really straightforward. Insulation thing, I hope everybody understands that insulation has to have an air barrier or it doesn't work. The best way to describe this is it's like a sweater in the wind if it doesn't have an air barrier. It's like a down jacket if it does. One works, one doesn't. Going to talk about water-resistant barriers, WRBs, weather-resistant barriers. People call them all kinds of different things. House wrap is the most common one. I stole this drawing from, I think, Journal of Light Construction or Fine Home Building. A lot of good brands out there. There's woven and non-woven. My preference is for the non-woven stuff. The woven stuff basically tends to not hold up very well, and it's perforated. It's got holes in it. That's how the vapor gets out. The non-woven is a spun-bonded polyolefin. It's Tyvek and a few other brands. That can be an air barrier if it's taped properly, although most of the manufacturers have tended to back away from calling them air barriers. They're mostly talking weather barriers now. But the spun bonded ones, they are basically water resistant, thoroughly water resistant, and allow vapor through. The one thing that's really important, anybody who's putting cedar siding on a building, there's a real compatibility issue with a lot of house wraps and cedar siding. It will, yeah, I think it's a tan, I think I can't remember, I don't know what it is. Something in cedar siding will degrade house wrap. Yeah, so if you're using cedar siding, you definitely want a rain screen or something, or use something other than a house wrap. The other thing, I like the integrated with sheathing products. Huber is probably the biggest one we see. GP Force Field, like used on your house. LP makes one, and GP makes several of them. They are really good air barriers. But the one thing I want to say is that every product is fine if it's installed right. And 99% of what I do is telling people to follow the directions because things are not installed right. Self-adhered, has anybody ever used a self-adhered weather barrier here? I have not had personal experience with them. They are very good products. They're complicated, and there's a workmanship issue. The last one is fluid applied, which fluid applied is a great product. Again, if installed properly. If you ever choose to use this, make sure it is, I'll get to, you have to make sure it's gauged properly because people can put it on too thin and then it doesn't really serve much purpose. The weather barrier details, sealed at the windows and doors, plane changes, seams, all the pipes, wires, and ducts. We do a lot of multifamily stuff. They have 20 or 30 electrical service cables coming out of the wall. There's going to be a whole bank of meters. And I make sure they seal around every single one before they put the meter bank on, hopefully. Has to flow down and out. I can't count the number of times I'm driving around and see people putting house wrap on walls and don't understand that water flows downhill. They reverse lap house wrap, and it's like, I have to restrain myself from jumping out of the car and yelling at them. It is vapor permeable. It is not a vapor barrier. I've seen lots of drawings with architects with an arrow pointing to the weather barrier, calling it a vapor barrier all the time, constantly. House wrap installation. Use the right fasteners. Use the right lapping. Do the right taping. Make sure the fenestration is installed right, and the mechanicals. One of the first building enclosure projects I worked on, Tiff. One of the first building enclosure projects I worked on, it was a 100-unit building. They stapled the house wrap. Yeah. They went up on a lift with pieces of tape and covered up every staple on a 4-story, 100-unit building. The integrated with the sheathing, there's tapes. The liquid sealants are great. You have to watch the fasteners. Overdriving the fasteners becomes an issue. Underdriving the fasteners. I have dozens of pictures where they just drive the fasteners through the tape. You can't imagine the things I've seen in the field. And like Huber allows a reverse lap. LP doesn't allow a reverse lap of the tape. You just have to, again, it's making sure you follow the instructions. That's really the key. Self-adhered, just follow the instructions the way it goes on. And fluid applied, I love the little magic caulking gun there showing, but as I was pointing out, the key about fluid applied, it has to be gauged. If you ever specify this, make sure they take pictures of the gauge showing you they have the right thickness throughout the building. And then, it's this little piece of metal. Okay. It's got mills on it, and you just stick it in there. And like for this example, the 3 has some material on it, the 4 doesn't. So it's between 3 and 4 mils. They have these little gauges. They go from like 1 mil to like 60 mil. And these fluid applies are going to be sometimes 20, 30 mils, maybe more. Window and door installation. I'm going to talk about this a little bit. You want to back dam preferably, because as Joe always says, there are 2 kinds of windows. Windows that do leak and windows that will leak. So you want to make sure that the water has a way, can't get into the building. Flanged units in house wrap. This generally works pretty well. I mean, if you follow the instructions, it doesn't leak. We test a lot of windows with house wrap. We actually see more windows failing because people put cheap windows in these multifamily buildings. The installation generally works okay. For non-flanged windows, I like people to use this Tyvek, makes a little flange you can just stick on a window. I can call it VersaFlange or something. It's got adhesive on 2 different sides. And you just comes a little right angle flange, just stick it on the window, stick the window in the opening. It's a good way to do it. We see a lot of storefronts in our projects. There's also non-flange windows. We try and get them to put it in first, especially in a masonry wall, because I may not have that image there, but the way the storefront manufacturers want you to install a window, install the frames is, they want a seal between the frame of the window and the weather barrier, which is behind the brick. And often storefronts go in after the brick. So if it goes in after the brick, there is no physical way to get there. So we have a way to do that, which I'm going to talk about in a second. But so we like them to get this in first, put a sill pan in, seal it to the weather barrier. It can be tape, it can be fluid applied, it can be backer rod and sealant, whatever you want to do. Just seal it to the weather barrier. Non-flange with trim, this is pretty standard. Seal this is basically sill pan. Just pull these off I didn't have a good picture, I just pulled them out of different magazines and things. Seal the bottom, seal the sides, put trim over the top flange. It works fine. Not going to lose much there. These windows are kind of hard to test because windows to be tested for water leakage like we do, they have to have a design pressure. Wood windows don't have a design pressure, so we really can't test them. So replacement windows. We have a lot of projects, affordable multifamily projects that every 15 or 20 years they get new tax credits and they have to replace all this stuff. So they replace windows. And replacing windows in existing brick walls is really hard, and we figured it out. So here's the theory. You basically integrate the existing weather barrier with the jambs all the way to the inside, get a sill pan in, and you have to make sure that it's got flashing into the lintel. Then you install the window. Then you seal it on the inside. So what you've done is you brought the water barriers all the way to the inside frame, and you seal it on the inside, and you don't worry about the outside. And this can be done with it can be done with any kind of window in a new brick wall or an existing brick wall. And we've actually got this going on some replacement windows. So this is what we did. This has been working on a project. So they were able to put tape, kind of connect the tape. They actually took the old window out, cut the flange off, basically got the tape worked into the opening, wrapped to the inside of the opening. They put a sill pan in. They actually have a two-sided sill pan, a left and a right, got set in sealant. The tape comes down over the sides of it. We get sealant. Sealant gets set at the back of the back dam. That's going to seal the window in place. And then the window goes in, and that's the sealant there. It hasn't been put in yet. And they're going to be backer rod and sealant all the way around the window. So again, we've got the seal on the inside, and the weather barrier turns all the way into the inside. So we don't care what happens between the front and the back of the stud. Yeah, this is actually, I worked that with Joe. I asked him about it, and he gave me this suggestion, and we started to do it on projects. I just done another job the other day and got some new pictures. Mechanical penetrations. There's all our mechanical wires coming through. HVAC. I really like these. The one on the right there is quick flash. That's right. Plan reviews. We do a lot of plan reviews and find things that people are doing wrong. So the first thing is, and I did this on a set of drawings today. They showed the tape over the bottom flange, which is just not the manufacturer's recommendation. It's just you don't tape the bottom flange because that way water can build up and not get out. And the other one we see, which is really interesting, and this happened on a project. This is a flanged window with trim around it, which we see a lot on projects. They put sealant between the top trim and the flange. And this is a project we did up in Jefferson, Georgia. And we tested all the windows before the trim went on, and they were fine. Then the building started to leak. And what happened was this became a dam that backed water up all the way. They had to go and take this caulk out of every window in the building. And it's like, we didn't really think about it, and we figured it out. So now this is one of the notes we put on every drawing we get when they put that piece of sealant there, because it's a potential for a leak. It's actually almost guaranteed to leak.
So no background, no sealant.
Yeah, you want to make sure there's always a path for the water to get out. And when you dam this up, there is no path for the water to get out. Vented rain screens. This is the single best thing you can do to keep a wood frame building from rotting away. Because there's a couple issues. When you put your siding, well, first of all, brick veneer has a natural rain screen, as long as you don't clog it up and don't clog up the vents. Yeah, vinyl is a great rain screen, yeah. Most sidings, when you put them right up against the water barrier, there's two issues. Capillary action can have water on the nails can work its way into the sheathing, and vapor drive can get into the sheathing. Wall gets wet, sun hits it, it drives the vapor into the building. When you have that gap of a vented rain screen, any water that gets through drops down. Any vapor that gets through either vents up and out or condenses and drains out. And it's simple, it's straightforward. You have to make sure you have the vents. So when they go to paint the house in 10 years, they shouldn't caulk the gaps. I have a gap at the top of my house, and I have to remember in a couple of years when they paint to not caulk that gap. This is one product. This is Obdyke Home Slicker. It's just a sheet you just lay on the wall. It doesn't really compress, works great. I actually like bumpy house wrap as an alternative. It's not a bad solution if you can't go full rain screen. And then this is essentially what we got out here, just strips. You just put on the building horizontally or vertically and nail your material to it. Wall finishes, stucco or masonry allow for drainage. I think this is one of the best things you can do with a masonry wall. It's called MortarNet is the brand, and it's designed so that all the crap that goes down there leaves a vent space. And then we also recommend cellular weeps and not tubes. We were actually at a project, they were having some leaks the other day, and they went through and literally every tube was filled with pollen. Some bees were coming out. I mean, they were sticking a little screwdriver in there, and they were pulling out clumps of pollen. It was, yeah. Yeah, well, the cellular weeps, they're like a full height of the brick, and they're like a little honeycomb, yeah. Yeah, basically, yeah. Okay, kick out flashing. If you ever have a roof that terminates in a wall If you don't put in kickout flashing, the only place the water goes is in the wall. There is nowhere else it goes but in the wall. If you want to see, Google kickout flashing and you will find hundreds of pictures of rotting walls that do not have kickout flashing. It's one of my favorite things to Google. Insulating existing walls. So this is an interesting one. I know you and I slightly disagree on this, but I think we have to be really careful about insulating existing walls because if that 100-year-old house has been fine, when you insulate it, you run some serious risk because the chances are there isn't a weather barrier or isn't a solid weather barrier. There probably isn't good flashing around the windows. This is a reasonably good solution if you have the interior opened up on a building and you don't have a weather screen. Here, this is actually this picture's not my house, but I did this exact same thing in part of my little 100-year-old house. I had studs and siding and nothing else, and I opened up some walls. I didn't want to not insulate them, but I was worried about it. So I literally ran felt paper around and spray foam. It gave me a very good air seal and gave me basically a drainage gap behind the siding. It's not perfect. You know, it doesn't really you can't really do it around the windows and things like that, but it's better than nothing. We do a lot of inspecting or observing water control layers. We look at kickout flashing. We just look at windows, make sure they're sealed right, nothing on the bottom. This is my favorite. This is a picture from Owens Corning, and there are 2 mistakes in it.
It's not sealed at the bottom.
It is sealed at the bottom, and there's no kickout flashing.
Oh, yeah. Oh, yeah. It's the very left, upper left.
Yeah. And then we test water control layers. We do this ASTM. Does anybody know what ASTM stands for? Another stupid test method. So we do ASTM 1105 testing. It's a spray rack. It's a calibrated spray rack. We have to test it every 6 months to make sure it flows the right amount of water. We actually have 3 of them. We usually do negative pressure. Sometimes we just have water. The negative pressure, we put sheet plastic on the inside, use a duct blaster fan to run the negative pressures to a set pressure. It's based on the design pressure of the window. The design pressure varies based on the location.
What's typical?
It's 35, the design pressure over 35, I think it's 35 pounds of design pressure. You basically do that to 15% of that. It's just, I honestly don't know where they come up with these numbers, but like in hurricane zones, we're running at 50 and 60 design pressure. We run about basically 4 5-minute cycles. And it's interesting what defines failure. Water that does not come in behind the interior face of the window is not a failure. So if water pools on the parting rail, but doesn't fall to the inside, it's not a failure. We see most failures with these crappy vinyl windows. The windows fail more than the installation does. Sometimes the installation fails. We'll go out there and spend a day testing, test 6, 8 windows, depending on how much we can get to it. We do them on lifts. It's fun. And when a rack falls off a lift, it breaks. Yeah, we've experienced that. Talk a little about roofing. I've learned some interesting things about roofing. You actually sent me this document. Thank you, Michael. Yes. So the code requires on insulated roof lines, it has to be air impermeable insulation above or below the roof deck. That can be roof deck insulation. It can be rigid insulation under the roof deck, on top of the roof deck, or closed cell spray foam. They consider open cell.
That's still there.
Oh, it's air impermeable, right? Okay. But it does create vapor issues, oddly enough. Yeah, and the open cell foam is the excess humidity in attics, which the guy from Owens Corning was here and talked about the whole building science stuff, which we're going to go into now. The insulated roof lines is I really like this stuff that they're doing. For those of you who weren't here at that other presentation, Building Science did this wonderful research, which they are working to get into the code, I think. I don't know when it's going to hit the code, yeah. So essentially, if you build, this is where you can use air permeable insulation in an insulated roof line. You have to have a vapor diffusion port. So it's essentially, it's a ridge vent with a vapor permeable, air impermeable covering over the ridge. This allows vapor permeable, air impermeable.
Yeah,
so
it's an air barrier that water vapor can dry.
An air barrier that vapor can get out of. So this allows you to do just cellulose or fiberglass in the roof line, and the vapor comes out. It can be conditioned or an unconditioned attic. So you basically get rid of all the vents, and it works in climates.
And it's not.
Yeah, Yeah, and it works in climate zones 1, 2, and 3. Doesn't work in colder climate zones. Low slope roofing. This is primarily going to see this in multifamily, but I saw a presentation on this actually at summer camp a couple of years ago. I don't know if you remember that one. Terrified me. We're not seeing it so much anymore, but developers do truss roofs, fill them with insulation, no roof deck insulation. And what happens is you get moisture in the cavity, it condenses and rots the roof deck. This is super critical in climate zones 4 and up, but it does have potential here. I'm getting calls back from clients about this. So basically, you need essentially roof deck insulation or spray foam insulation under the roof deck. And what I learned is that this is actually in the code. It's actually, 806. It's in the code. It's like you have to do it. It's just, and people are finally agreeing that they have to do it. But this is what roofs look like in cold climates after that. So what we're getting most of our multifamily clients to do is just plan on putting at least an inch of roof deck insulation down on top, and then they're fine. So low slope testing, we do some of this stuff. I've done some infrared testing of roofs. You basically show up on a roof with an infrared camera after the sun sets, after it's usually, you need to have had to have rain like in the past couple of weeks, but it be dry. And the wet areas are hotter. You can actually see this that's not my picture. I had to steal that because my roof was better. We do impedance scanning, which is a really cool machine. It looks like a lawnmower. It sends a low voltage current through the roof, and depending on how much resistance there is, it identifies wet areas. And we had a team go up to a new multifamily building in Nashville recently and found 5 leaks in the roof. Yeah. If you have, probably not many houses, but if you have a super critical thing like a museum, a laboratory, a hospital, there's something called electronic leak detection, which is this, or usually like little ski poles. Electronic leak detection requires a layer of conductive material below the roof. You then flood the roof and you walk around and it pinpoints holes in the roof. It will find any hole in the roof. It's very good. It's really good. Like if you're gonna do like a plaza over a parking deck or something, you can actually check, you can inspect and guarantee there's no leaks in a roof before you put anything on top, before you put like an overburden on top of it. And then there is a little bit of flood testing, which the challenge with flood testing is it can cause damage and you often have no idea where the leak comes from. You can see the leak on the inside, but you can't tell where the leak is on the outside. We do some of this on balconies, which are actually a little bit easier. There are balconies. These products tend to be really good. I've had very little trouble with these balcony waterproofing products. The railings are a challenge. My favorite one is when they actually build up a plate that they seal all around it and then you just weld the railing to the plate. There's a couple other methods to do it, but we hopefully don't have too much. Getting it integrated with a weather barrier is often a challenge. Make sure they do it right. Decks, you definitely need a good ledger flashing, and I would highly recommend you put some self-sealing tape on top of all the joists. This is kind of almost the equivalent to a rain screen. This will extend the life of your deck a lot. Below grade waterproofing, waterproof foundation walls, protection board, membrane, drainage mat, pipe and gravel, just pretty straightforward. I really like the idea of a capillary break. If you have any living space below grade, a capillary break can be a paint, can be a plastic sheet. What that does is that will keep the moisture from migrating from the footing up into the wall. So if any condition space below grade, anything you want to keep dry below grade. We're getting into moisture testing. We're on multifamily projects which take a long time to get built and get very wet. And we're out there. This is actually a really nice moisture meter. This is an expensive moisture meter. You can buy cheap moisture meters that work just fine. You just go around and make sure you've got below about 14% moisture in the wood. And then it's also good to check the moisture in concrete, especially if you're putting down like any kind of floor like vinyl floor that's gonna be vapor barrier or linoleum or something. Making sure the floor is ready. They're in the instructions for the flooring. I'm sure it gives you a maximum moisture content in the floor. And it's not a bad idea to check it. Air control, make sure the air control layer to the exterior, it's the sheathing, foundation, the ceiling or the roof. Chases, again, this is mostly multifamily, but trash chutes are exterior walls. Sometimes the elevator is outside the building envelope. Sometimes it's inside the building envelope. We just, that's one of the things we work out with. Like,
What's your design preference outside?
Well, it depends. If you can get it inside the building envelope, that's the best. And often that's insulating over the elevator cab. But sometimes we have buildings where it goes to a parking garage on the bottom 2 levels. So it can't be inside the building envelope. So that's just some of the things we have to work out with the client. So they have to insulate around the shaft all the way up. Interstitial in a multifamily, the bands are really important. And the walls, floors, and the ceilings. One of my employees who actually didn't make it here today said she smells the pot smoke from her neighbor in her apartment all the time because it's really poor air sealing. When we inspect the air control layer, architects like bump outs and chases, and they make me crazy. So this is a note I put on my drawings all the time. You know, the air barrier has to be there. The air barrier has to be there. What I always tell architects is build the simplest box you can. That's the air barrier. Tack whatever you want to on top of it. Don't do things like this. This is an appendage. I had a design professor in college once. He called things dingles. And you think about like old cameras used to make that little pieces of sheet metal on them. Anything you could pry off that hit the floor and went dingle that served no purpose to the product was just something extra. And those are what I call dingles. So this is a lot of what I talk about to my clients. So when we inspect the air controller, we inspect it rough. We look for holes. You can see a little hole there. In multifamily particularly, we want the chases capped at the ceiling because the ceiling line is going to be your air barrier. So we need to make sure they cap every chase. I like that one. Mechanical holes, you know, plumbing pipes. Especially in remodels, the mechanical closets in remodels drive me crazy because they come in and swap out the water heater. Then they come in and swap out the furnace and nobody patched any of the holes in the closet. So I'm pushing them up, take all the equipment out, patch the closet, and then put it all back in. So that's what we're working on getting to do. Pipes, wires, testing the air control layer. Most of you have probably seen a blower door test. You can use smoke. You can use infrared. It's great if you have enough of a temperature differential. Infrared's wonderful just to see where the leaks come in, around the receptacles, around the floor. Okay, the vapor control layer. These are my images from Building Science Corporation. My favorite, vinyl wall covering. This is the most horrible product in the world for a house. Anybody ever been to the Hyatt in Savannah on River Street? You go down the elevator and you come into this tunnel that takes you out to River Street. The mold hits you when you walk into that tunnel. And I was there once and I peeled back some of the vinyl wall covering and saw the mold. So in case you don't know, what happens is there's air conditioning running, there is moisture in the walls, and the moisture migrates to the cold, comes through the drywall, stops at the vinyl, and the paper molds. When I built houses in the early 80s, there was a company called Guaranteed Watt Saver in Georgia that was giving you a guaranteed electric bill when they put polyethylene in the walls. I never used them, but that is terrifying as well. All that does is guarantee that your walls are going to rot because it is a vapor retarder, but it doesn't keep the vapor from getting into the wall. It just keeps the vapor stuck in the wall. So wrap it up, the building control layers. You got your water control layer, your water shedding layer, your water control layer, your air and vapor, and your thermal. And each layer has to be continuous and complete. Just a little bit about us. This is where we work. I think we're in 24 states. These are the things we do. We do building enclosure work, obviously. And probably the other fun thing to do is we do large building blower door testing. We did the Candida building. We did ASHRAE headquarters with lots of fans. We did a federal courthouse in Huntsville with 12 fans, which almost killed me. And actually, we're about to do, there's new dorms at Georgia Tech, which were designed to passive house. They're not getting certified, but they're targeting passive house. So we're going to be probably testing that building as well. That's it. Yes.